All right, so for this week's project, we're going to be taking a look at a viewer submitted unit. This is a Sony Car Equalizer. This is model XE-700, and this comes from Jock, who lives down in Louisiana. He got in touch with me and asked me if I would want to take a look at this for him. So I told him, please send it on up here to me. This is going to be from that golden period of car audio, probably late 80s, early 90s from the looks of it. And this is a 1 DIN size flat-faced equalizer. And I can't imagine how amazing this would look professionally installed in a car with a flat-faced DIN size head unit right above it. He's saying that there's an issue with the display. The display is not working. And this is a totally passive unit. It has 1 set of inputs coming into the unit and 2 sets of outputs going out. So you need a minimum of 1 amp to operate this, but it does have provisions, of course, for 2 amps. And there's only 3 wires you'll find on the back of this. There's a positive, a negative, and a remote turn on. And so we're gonna see if we can figure out what's going on for him. As always, we'll come in, we'll have a look at the front, check out some of the buttons and the features, and then we'll get it opened up and see if we can find out what's going on. Our intro music this week, we're checking out the 2005 collaboration album between Tony Iommi and Glenn Hughes. And in my opinion, this would be one of the hardest albums of this time period for this type of music. And so let's check out one of my favorite tracks from this. This is called Dopamine. We'll have a listen to this and then we'll get started on the Sony. All right, let's pick back up and we'll take a look at the buttons provided on the front of the unit. And given the fact that this has got a remote turn on lead, you'll find no power button here, but assuming you have it wired correctly, as soon as you turn on your head unit, then of course the power to this is applied and it's ready to go. On the far left, we have the EQ button, which I assume you could just bypass this unit altogether and just work off of the bass and treble from the head unit. We have one labeled SENS. I'm not sure if that's sensitivity. Have to look it up in the owner's manual. We also have a dimmer button for the display and then a select button. And I would assume the select button basically just cycles you through all 10 bands here so you can make whatever adjustment you want. We also have level, positive and negative, or plus and minus. I assume that adjusts the level of the display or possibly the level of the effect that the EQ is creating. And then right below that we have 1, 2, 3, 4, and 5. I'm going to assume that that is for presets for the equalizer when you set it up for different types of music. And then they have some built-in presets for you here. It looks like pops, rock, jazz, classic, and one labeled BGM. Not sure what that is all about. Up top to the right, we have display A and display B. I assume this thing will cycle through a bunch of different types of spectrum analyzers or maybe even some scrolling text across the front. And then below that, we have a button labeled bass. So flipping it around to the back, not much to look at here. You're going to get your 2 sets of RCA outputs and your 1 set of RCA inputs. And as mentioned earlier, you get 3 wires. You get a positive, a negative, and a remote turn on. And the positive, of course, is yellow, just alerting you to the fact that this should be a constant 12 volts at all times. And then the blue one is going to be your remote turn on. So I guess the next step, let's go ahead and get the power supply involved here and let's get it fired up and see if we can duplicate what he's talking about. So give me a moment for that and we'll pick back up. All right, picking back up with you. Got the unit wired up to the power supply up here. Not drawing anything excessive. Got our line in and line out wired into the tape monitor of the bench receiver, so it should act as if it were a home EQ. And we do have some indicator lights here, but nothing on the display and absolutely nothing as far as sound. When we kick in tape monitor, it goes completely silent and there is nothing happening here. Absolutely nothing. Other than a few of the buttons, backlighting for the buttons is on, but that's pretty much it. All right, next step, let's go ahead and get it opened up. Strangely enough, it feels heavy, like there's a lot in it, so let's open it up and see if we can spot anything. So give me a second for that, and we'll pick back up. All right, as we come back in, went ahead and got this board out, which did require actually removing the front face mask, and I went ahead and took the bottom board off too. Or excuse me, this is the bottom board. I went ahead and took the top board off too, since in order to get the back of it off, I had to remove 2 screws from that board. So now we're getting down to where we can kind of see what may have caused all of this. And it's pretty easy once you get it flipped over. And you can see that we have some of these red capacitors here. I believe these are ELNA capacitors, and these are known to cause trouble, especially in CD players from around this time, probably other things, but these are all 100 mic at 10 volt, and I bet you we're going to find this is the reason for all of this discoloration, because they leaked down through there. And it could be some of these other ones too, but these are the ones that are notorious for it. Now, what I find interesting is these apparently are in the audio circuit right here, but I did notice some more. One in particular right down in here in some sort of a power supply configuration, so that's probably being responsible for the no power scenario. Also, when I was taking this apart, I was able to confirm, if you take a look on the right hand side of this display, there's like a little rubber boot to the right and a little rubber boot to the left, and I bet you there's a fluorescent display tube running across the back of this. And so if there's more of those capacitors, and there are, I've seen a few more down here on this board, then that's probably where our no power situation or bad power situation is coming from. So I think I'll go ahead and mount the camera overhead, and let's go ahead and get a couple of these out. We can confirm that they are nice and wet underneath. I can tell you already that they are, though, but they're going to have to be changed. So let's go ahead and start getting some of this cleaned up and get these changed out. See if we can get on the road to get them back in operation. So give me a moment for that. All right, so picking back up, I got you set up overhead now, and we're going to concentrate on these 2 caps on the outside right here. What I'm going to do is I'm going to add some solder to these to make this maybe a little easier to get these out. And what this is going to do is just stir up all the liquidy goo that comes from these things when they start to get like this. And sometimes you can't even solder to them. Yeah, it doesn't look like this one will even have any solder adhere to it. And these things do stink terribly. All right, let's just kind of move forward here and see. And we got to be really careful of this area right here. And there's a chip capacitor right there. We definitely don't want to create a problem there. I know we're going to be doing some trace work on this. I'd be surprised if these traces survived these caps being like this. go. Maybe. Looks like it's moving. Let's see what we can do about this one. Might can take the solder wick, kind of condense this one to come apart maybe. But I think the trace is probably too far disintegrated. Yeah, this looks bad. All right, let's clean that up with a little acetone and see how bad it really is. The thing is, with this kind of stuff, you got to be really careful because you don't want to start destroying traces around things that could possibly, I don't think there's double-sided traces here. Actually, that looks better than I thought it was going to look. But you can see there's a trace issue right there, I bet you. I bet you. I'm looking at it through a magnifier and I can see there's something not right there, but I don't know if the trace is completely severed all the way. All right, let's see if we can get that one cap out. I don't know about the other one. Yeah, that's what it looks like. Not too good, actually. Yeah, that doesn't look too good there. Now, let me see if I can raise the camera up and we'll take a look at the board on the other side. That's where we took that cap out right there. And you can see, boy, I hope there isn't any damage to this thing. You can see it leaked. But again, I hope there isn't any damage to this. That would be irreplaceable without another unit that's doesn't have it damaged. All right, I'm going to clean this up. I'm going to go ahead and get this cap out, and then we'll start working on cleaning on the other side of the board and see what it looks like. So give me a minute for that, and we'll pick back up. All right, picking back up with you. Went ahead and got these traces cleaned up. These are where 2 of those 100 mic at 10 volt caps were. Got these pads cleaned up real nice, and right here on the ground pad of the one cap, you can see and I checked this, there's some continuity there, but it eroded quite a bit of that material away. So once we put a cap there, we're going to go ahead and jumper over to this point right here where that trace goes to, just to make sure there's not going to be an issue. Went ahead and took a cap out right here that was unrelated to the 100 mic caps. This was a 10 mic at 16, and the leakage from these had kind of ran down and pooled in this area right here. And so I pulled that cap out, cleaned up these 2 pads, and I'll put a different cap right there. Touched up the connections on this chip piece and then on this assembly here. Coming over to the other 2, everything looks pretty good. These pads cleaned up a little better than these did, but there was a cap here that suffered the same problem as this one did, is the leakage kind of pooled around this area. So I pulled that cap out, which was unrelated to the other 100 mic at 10 volt caps, cleaned up the traces and put a different cap back there. So there shouldn't be any issue with that. Let's flip the board over and we'll take a look at the component side of it. Getting a little different story here, coming underneath here. And right here, we do have one double-sided trace, but there doesn't seem to be an issue with this. It looks clean. Looks like it wouldn't have any problems making a good connection, so I don't think we need to worry about that. But coming over to the other 2 over here, it's clear, and this camera will not get in close enough, I don't think, for you to see, but you can see the top side of these traces is eroded away to the point to where once I get the components in, we're going to have to jumper out these traces in an effort to make sure that there's no problem with a connection problem there. It looks like there might be some material left there. I haven't even rang these out with continuity, but I'm just not going to risk it. We're just going to go ahead and put jumper wires there if we can. So I think the next step is I'm going to go ahead and put some different caps in here. Caps I'm going to use, I pulled from a new old stock signal board at my friend's shop. They are, I think 100 mic at 16 volt or 100 mic at 25 volt. And these caps are pulls from a circuit board, but the board was brand new. And so I'm going to use those in place of the ones that were there. I think size-wise, they're just a little bit bigger, but they should be just fine. And we shouldn't have any trouble whatsoever. So I'm going to go ahead and get those swapped out, and then we'll pick back up and we'll have a look at the bottom side and see what we can do about that. Also, I went ahead and ran ESR on all of the non-ELNA caps and found all of these to be fine. These were all within usable tolerance for my ESR meter. And so we're not going to do anything with any of this. We're going to leave all this alone. But I think that any of those you find that have high current pulling through them, power supply wise, that's where you're really going to find the leakage and you're going to find the problem. So let's pick back up after I get these populated, and we'll see what that looks like. All right, so I'm picking back up with you. It's going to be about an hour later, give or take. Made a little bit of progress here. The two capacitors, I think I incorrectly identified this capacitor as one of the 100 mic ones. This was a 0.68 at 50 volts, and this is the one I removed after some of the goo had kind of pooled in this area right here. But the two in question on this side of the board are this one and this one. This is the one where we had the damaged trace. So basically, pull the lead through the hole, bent it over, scraped away some of the material from the board to expose the copper, tinned that copper, added the jumper, and connected it at the point that it goes to. And this one, no problem whatsoever. Went in like a boss, as they say. Coming over to this side, no trouble whatsoever. These went in perfectly, no problem. Did touch up some connections right through here after looking at those under magnification, so that's all looking pretty good. So let's flip it over and I'll show you from the other side. And basically, what I did, how I handled the situation with the top traces, there was a trace running from here to the connection of the capacitor on through underneath this IC. Is I took a resistor lead, wrapped it around the lead of the capacitor, soldered it, then put it in place, and then soldered that to the pads. Of course, the same process, just scraped away some of the material to expose the copper, and that way that gives us the continuity from the bottom to the top trace. Same deal on this one here. There was just that one trace. Went ahead and touched that up by scraping away a little bit of the material and putting the capacitors in. So everything is looking pretty good. Doesn't seem to be any trouble with any of this. These caps were 100 mic at 16 volt, or excuse me, 100 mic at 10 volt. And the ones that we're going to replace on the bottom board, we're going to up those a little bit. These are just being used in the audio section, so we can replace cap for cap, same value. I don't feel there's any problem at all doing that. But when we go to the power supply on the other board, we're probably going to up the value of these a little bit. So I think I'm going to go ahead and take a break. We'll pick back up on it tomorrow, and we'll start on the bottom board. And hopefully, this board does have some issues. You can see there's one right there. And we'll look over the entire thing just to get an idea. But for the most part, this was pretty tedious because there was a lot of work having to be done in the magnifier, and some of these traces are micro small to see. even with the magnifier. So got it all mopped up, so we'll pick up tomorrow working on the bottom board and try to get the power supply issue resolved, but getting a little closer. So pick back up with you tomorrow. All right, picking back up with you. This is going to be day 2. And we've got to look at the top circuit board here. Got it kind of laid over where you can get a good look at the components and the layout of everything. I went ahead and removed the shielding off of the display back lamp driver circuit. And there's a few caps here, but all of this is looking real good. There's no apparent leakage on the top. There's no deterioration under the bottom. And these do check fine ESR wise. So I don't think we really need to do anything right here in this circuit. So we're going to make our way over. And right here there was a piece they had labeled battery mirror, which I'm not sure if that's just a DC to DC converter that they're using here, but that is where we found another one of the red caps. And there's also one over here. Now I noticed, and I don't know if the camera will actually be able to show it here, but we do have a trace that's horribly discolored that's running over into this power supply circuit, or I'm assuming this is part of the power supply here. But we have a lot of caps here that are not red, but still we're going to be checking these and confirming that there is any ESR issues. And right by that red capacitor, I'm not sure the camera will show what we're trying to see, but there is a diode that's kind of sandwiched in there that looks really discolored, and I'm not sure if that's just its natural color or there is some issues with it from leakage from that red cap. So I think what we want to do here is I want to go ahead and get these red caps out and start looking into this trace, how much damage may be done underneath here. I don't think there was any problems with this. This looks totally fine. This is a sealed piece, and once we get this taken care of, I'll put that back in. But this is the only thing I'm seeing, so we're going to go ahead, and we know that this has got to be addressed, so we're going to go ahead and take care of this first, and then we'll check our operation and see if things have changed. But now that we've got the obvious issues, once we get these obvious issues corrected, we'll find out if we have restored power to it. If we have, fantastic. That's probably all that was wrong with it. If not, then we can actually start working on the original problem. But until we get this taken care of, I don't know if this is the original problem. All I do know is that it is a problem and it's got to be taken care of. So I'm going to work on that, and then I'll pick back up with you, and we'll go a little further. All right, picking back up with you for kind of a status update of the progress I've made. Went ahead and reattached the shield on the lamp driver circuit. Everything under there is fine, so there's no need for that to be off any longer. Making our way over here, went ahead and removed the one leaking 100 mic at 10 volt cap, and I replaced that one with 100 mic at 50 volt. And there was some consideration about the integrity of the trace that was running along the edge of the circuit board leading over into the other part of the power supply. And I did confirm that that trace was definitely open. And so what I did was installed a jumper wire, and it connects from this top mounted jumper all the way over to this one right here. That's where that actual trace goes. And the capacitor that caused that issue was another one of those red 100 mic at 10s that was in the center. On left and right of that cap, there's 22 mic at 16. Went ahead and removed those. There was no problem with either one of them, and they weren't leaking, but I needed to make sure I knew where that trace was running to before I put a jumper wire there. So I'm going to replace the two 22 mics at 16 with 47 at 25. This will be another 100 mic at 50. But the big takeaway from all of this is the diode that was in question right there in that circuit. That Zener diode, and as it turns out, that diode is shorted. And at this point, we're not really sure what the value of that is. I don't have a service manual, and I don't see one in my future. I'm going to look again to see if I can find one online, but if not, I'm going to take that over to my friend's shop, and we're going to put that under a microscope and see if we can pull any numbers off of it that might help us in cross-referencing what the value is. Otherwise, battery mirror is soldered back in place. I'd probably argue that that shorted Zener was probably the reason why the power of this thing wasn't coming on. Of course, the capacitors were just the another underlying issue. But that Zener probably shorted probably about the time that trace opened up, or some of that goo got in there and caused some kind of a continuity type of issue that would have shorted it out. Not real sure, but definitely know it ain't going to work with a shorted diode in the circuit. So that's the progress I've made. The next step is finding out the value of that Zener. Once I find that out, then we'll put another one in it. I would say that it probably would work with the Zener out of circuit, maybe. So if I don't find out the value, we will definitely fire it up without it in there. But I'm going to go ahead and finish with the capacitors and work on the diode thing, and I'll pick up with you once I have some information on that. All right, I'm picking back up with you. This is going to be day number 3, and yesterday I was able to find out what the value of that diode is, not for having a service manual, but we were able to put this thing under a microscope and pulled off a 5 and a 6, which led us to believe that it was a 5.6 volt Zener, and I did have one and got that installed. Went ahead and populated the rest of the capacitors on this. Due to the kind of size of those capacitors, the way everything was kind of a little bigger than the original ones that were there, I went ahead and stood that diode upright, bent the one lead over, put a little heat shrink on that lead to prevent that from creating any problems. And I think we're ready to move on to the testing of this and see what progress we've made in that respect. Now, this has been a pretty long video so far, and I know there's a lot to the operation of this. So I think what we're going to do, I'm going to go ahead and end this, and we'll pick up with a part 2, looking at the testing, and if it is working and working correctly, we'll also want to do a little, spend a little time with learning the operation of this. This has a lot of features on it, and there does not appear to be any type of owner's manual online, not one that I could find anyway. And we'll want to know how to set the presets. We'll want to know how to operate the thing. So that'll probably spill over into a little bit of time. So let's go ahead and we'll put an end to this one now. And then from that point, we'll pick back up and we'll start part 2.